Enzymes are globular protein catalysts that speed up reactions without being changed by lowering activation energy. Life would be impossible without the existence of enzymes. Trypsin is an enzyme secreted by the pancreas in animals and found in the digestive tract. It is secreted by bacteria also, and this experiment is going to be testing bacterial trypsin. It digests dietary proteins. And our question for this experiment is, does pH affect its activity? Our hypothesis is that trypsin will have an optimum activity at a pH of 9, and this is based on results from other lab groups. Activity was monitored at pH 5 through 11 with 3 trials plus 1 native control with no trypsin. Control variables are incubation time and temperature, 47 degrees for 20 minutes, and a salinity of 0.15 molar. These were both chosen for maximum activity. The substrate is azocasein, a milk protein. For the experimental procedure, the salt buffer was first added, then the azocasein, then the trypsin. This was then incubated again at 47 degrees Celsius for 20 minutes, and TCA was added to stop the reaction. This was then centrifuged, removing the undigested protein in the pellet, and the supernatant contained all of the digested protein. This azocasein has had sulfonamide groups added that absorb light at 440 nanometers. So by measuring the absorbance of the supernatant liquid, the concentration of digested protein and thus the activity of trypsin could be determined. Negative control was used to determine spontaneous digestion with no enzyme. 3 trials were performed so they could be averaged and analyzed statistically. As far as our results, trypsin has an optimum activity pH range from 6 to 9. Although pH 9 gave us the highest average value, according to both the standard deviation and the t-test, the values from 6 through 9 were not statistically different, and therefore our data can only state an optimum range. The first trial data stands out. It was performed separately from the other 2 trials, so an inaccuracy in pipetting or a difference in incubation could have accounted for the difference. The hypothesis is not rejected, but further tests are required to determine its optimum pH range, as well as possibly eliminating trial 1 as an outlier.